This question comes from Jonah, who asks, what if the Sun were made entirely of neutrons and Jupiter were made entirely of positrons? At first glance, it sounds like a harmless thought experiment, but it's anything but. This is one of the most extreme what-if scenarios we've ever imagined. Picture it, a positron Jupiter orbiting a neutron Sun. On the surface, it seems almost like a giant atomic system. Electrons orbit protons, moons orbit planets, so why not positrons orbiting a neutron star? But physics is not that forgiving. Neutrons themselves carry no electric charge, yet they pack an incredible density. A sun made entirely of neutrons is, for all practical purposes, a neutron star. That means a star that's only about 20 kilometers across could weigh more than the entire sun we know. It's unimaginably dense. Now let's look at Jupiter. Positrons are the antimatter counterpart of electrons. They repel each other with tremendous force. Try to assemble 10 to the power of 30 positrons into a single planet, and the repulsive forces are so enormous that the cloud would immediately start flying apart. If we ignore relativity for a moment, each positron would accelerate outward at near light speed. But near light speed barely scratches the surface. The energy involved here exceeds anything we've ever seen, even in particle accelerators, and goes far beyond anything that can exist in a lab. These are energies approaching the limits of theoretical physics, far beyond the Planck scale. To make sense of this, I spoke with Dr. Mara, an astrophysicist who studies extreme stellar phenomena. She explained, the positron cloud would almost certainly explode, but the neutron sun's gravity is so intense that it could trap some of the positrons, creating something we can't fully predict. We're entering a regime where normal physics starts to break down. And that's where general relativity comes in. The mass of the neutron sun is so concentrated that it bends space-time dramatically. In fact, it's already on the edge of forming a black hole. Add the energy of the exploding positron Jupiter, and you might just tip the balance. A black hole could form almost instantly, before Jupiter even finishes existing as a planet. Dr. Mara's verdict is, congratulations, you've just created a miniature universe-ending experiment. Nearby star systems might not notice immediately. Gravity only propagates at the speed of light, so any catastrophic effects would expand outward gradually. But eventually, anything that drifts too close would experience forces beyond imagination, intense gravity, extreme radiation, and the violent annihilation of matter and antimatter. In other words, this what-if scenario starts with a simple thought about swapping matter and antimatter and ends in a cosmic catastrophe. A neutron sun with a positron Jupiter is not just a planet and star. It's a scenario where quantum physics, relativity, and astrophysics collide in the most dramatic way. It's terrifying, it's fascinating, and it's exactly the kind of question that reminds us just how strange and powerful the universe really is.